Section 10.2, Example 5 on page 602, we have not all conjectures turn out to be true. You should test your conjecture multiple times. You can prove that a conjecture is false by finding one counterexample. A counterexample is an example that shows that the conjecture is incorrect. For example 5, we have what is a counterexample for each conjecture. For part A, it says if the name of a month starts with the letter J, it is a summer month. In order to show that this conjecture is false, we want to show that the first part, the if statement, is true, but the then statement is false. So this doesn't actually say then, but after the comma, we could insert the word then. And if we can show that the first part is true, but the second part is false, the conjecture is not true. There are many examples where this is true. For example, June is a month that starts with the letter J, and it is a summer month, so is July. However, January starts with the letter J, but is not a summer month. So the conjecture is false. Not all months that start with J are summer months. Part B says you can connect any 3 points to form a triangle. Again, there are many cases where this is true. However, we only need one example where it does not work to prove that the conjecture is false. So here we have 3 points that are in a straight line, and you cannot form a triangle out of these 3 points. Part C says when you multiply a number by 2, the product is greater than the original number. There are many cases where this is true. For example, 1 times 2 is 2, and 2 is greater than 1. 5 times 2 is 10, and 10 is greater than 5. However, if we take a number like -5, 2 times -5 is -10, and -10 is not greater than -5. It is actually less than, and the reason for that is the negative sign. So when you multiply -5 or any other negative number by 2, the product is -10, which is less than the original number, -5. The word for this problem is written out on the next few slides. And now I would like you to try homework number 9 on page 603. Find one counterexample to show that each conjecture is false. For number 9, we have angles 1 and 2 are supplementary, so one of the angles is acute.